I got a comment on one of my older GameMaker videos a few days ago that said the attached project on that video wasn't working for whatever reason, and I went and looked at it with the intent of just fixing whatever the problem was, and it actually turned out to be a really old video, and I decided that I've probably got more to say about the subject than I did back then anyway, so I figured that this would be a decent candidate for remaking one of my old videos. So hello worldly crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about transforming objects in 3D space using matrices. So, this being a remake of an older video, I am going to throw this video pretty early in the playlist of 3D games in GameMaker. It's probably going to go right after the OBJ loading video because that's well, at least I think that's when things really start to get interesting when you're trying to make games. And when you start to load differently sized and shaped objects from files, that's also usually when you want to start thinking about transforming them in different ways. So how do you actually do this? So I actually did sneak a couple of lines about matrix transforms into that OBJ video, but we'll pretend that those aren't there for now. Just play along. We'll start from the beginning. So when you have an object in 3D space, such as this treasure chest, or this flat sheet that represents the floor, or whatever it happens to be, generally that object will be centered about the origin, so the 0 coordinate in space, and that will generally be true regardless of whether you load it from a file, you generate your model through code. And when you're authoring your 3D models in something like Blender, this is a perfectly sane way to think about things. But as soon as you bring an object into your game, it's going to be about 5 seconds before you want to start thinking about transforming it in different ways so that you can move an object around, so that you can change its size, change its rotation. In fact, in 3D level editors, this is such a basic operation that you almost don't even think about what's actually happening. So for this project here, we are going to be using the same treasure chest model that was loaded during the OBJ import video. It is just being drawn without any special transformation. It's going to be drawn by default at the world origin, so at the 0 point, at the 0 coordinate, just like everything else. So if I run this, we are going to see a slight problem, which I suppose is as good of a place to start as anything, which is that if I were to actually look around, the treasure chest is microscopic. And that is because one of the many eternal debates in the world of computer graphics is what the actual scale of stuff should be. Oftentimes you will see in 3D modeling programs that you'll assume that 1 unit of world space is 1 meter. Other times you'll see 1 unit is 1 inch or something like that. And the letter S in the word technology stands for standardization. Anyway, so because I'm just kind of assuming that I think I set it to 32 units of world space is 1 meter in this project rather arbitrarily when I started it up. We might want to scale up the treasure chest just a little bit, because this treasure chest was originally authored at 1 unit equals 1 meter. Well, let's go ahead and fix that. So there's a function in GameMaker which is called matrix build, and this is going to be your best friend for most of your 3D and GameMaker adventures. So this is going to construct a transformation matrix. There are 3 main things that you can do with the transformation matrix and a couple of other specialized things that you don't really do very often that I probably won't talk about here. Those 3 things are going to be translations, which are just moving something around in space, rotations, which are rotating things in space, and scaling, which I don't think I have to define those. Anyway, matrix build takes 9 arguments. There's going to be 3 for translation on the X, Y, and Z axis. There's going to be 3 for rotation, also on the X, Y, and Z axis, and there's going to be 3 for scale. So, for the time being, I will just set the translation part of matrix build to 0. I'm going to set the rotation part of matrix build to 0 also. And I did say that we would scale this thing up so that we can actually see it without a microscope. So let's just set our X, Y, and Z scale to 32. And you can, of course, have these values be different for each axis if you wanted to scale something up in a different way. If you wanted to, have it be different scales on different axes. Usually you don't, because it tends to look a little weird, but if you want to, nobody's going to stop you. So matrix build is going to return a matrix. This is going to be a transformation matrix, so I'm just going to call it transform, and we can just save that to a variable. This is just going to create a little data structure which represents a 4x4 transformation matrix. I will get into the math of what that means a little bit towards the end of the video, but this alone won't actually like do anything in your game. If you do want to have your transformation matrix affect something in your game, we can say matrix set, matrix world. So you actually can use matrix set to set the view and projection matrices when you're drawing stuff. I usually don't. I think most people usually don't. Most people would be perfectly happy to use the GameMaker camera system for this, for various reasons. But when you want to set the transformation of an object, you're going to want to say matrix set matrix underscore world. And the matrix that we're going to use for this purpose is going to be that transformation. Anyway, this scale transformation is now going to be applied to anything that we draw. And we only really want that to be applied to our treasure chest. We don't want this to be applied to like the UI or the ground model or anything else in the game, because that would be silly. So just like when you say something like shader set or like draw set color or GPU set blend mode or something like that, anytime you set a draw parameter in GameMaker, you most likely want to reset it when you're done, as we see down here with shader reset and what have you. There is no built-in function called matrix reset. So what we're going to do instead is the same way that you can build a matrix with some weird translation rotation scale. You can also matrix build a matrix which has you could say the default transformation, so no translation, no rotation, and a scale of 1. This is known as the identity matrix. There is also a function matrix build identity, which will do the same thing and slightly less typing. And if we save this to a variable, we could call this var identity, something like that. Oh, help. We could, once again, matrix set, matrix world, the identity matrix, and that is going to reset our transformation when we're done drawing. In this case, we're just drawing one object with the transformation. You're allowed to draw multiple objects in succession with the same transformation if you'd like. You're allowed to like set a different world matrix every single time you draw an object, which is usually what you end up doing. But definitely remember to reset the identity matrix when you're done drawing stuff, especially at the end of like your draw event, like the same way that we're resetting the shader and we're resetting the depth testing down at the bottom of this, because it will apply to things that anything that you draw after this. It will not be reset automatically anywhere. And if you're drawing like UI or something like that, you might find that suddenly your UI is being scaled up by 32 times if you do this, which probably isn't what you want. Anyway, now if I run this and back away from the world origin just a little bit, we can see that our treasure chest is indeed being scaled up, and we can actually see it now. That's great. So some other things you can do with this. You can encode multiple transformations in a single matrix build like this if you'd like. So if you would like to set, for example, position, let's put it at 100, 100, 0 in the world with no rotation and a scale of 32. You can combine multiple transformations into one like this, and it will generally work. So now we can see that instead of being like in the middle of the screen here, the treasure chest has been shifted over some distance. Most of the time this is fine. Let's toss some rotation into here. How about some, let's give it a 90-degree rotation about the y-axis. So this is going to give us a treasure chest that has been translated, rotated, and scaled all at once. If we want to make it dynamic, we could make it rotate in time. So something like current time divided by 100. So current time is a very convenient timing variable in GameMaker. It's the number of milliseconds that have passed since the game started, and if you can use that for some exciting timing related things. So for example, having this treasure chest just rotate slowly on the spot, and we can see that our transformation is being updated in real time here. So if you want to include your translation, your rotation, and your scale all in the same matrix build function like this, you're allowed to, and generally you can get away with it, but Well, for starters, sometimes that's not what you actually want to do. Sometimes you do want to have multiple separate transformations and then be able to combine them together in different ways. And also, the way that GameMaker does build its transformation matrices is a little bit weird, and sometimes you will get weird scaling artifacts if you try to rotate something and scale something on a non-uniform axis. It's not often that you actually run into that being a problem, but let's say that you wanted to separately define your translation. So I'm going to save our transform translation is going to be matrix build with the translation only, no rotation, and no, well, a uniform scale of 1. We need a comma somewhere in there. Let's say that we want var transform rotation equals matrix build. And this one's going to have no translation. It's going to have whatever rotation is up based on our time variable, and a uniform scale of 1. And lastly, var transform scale equals matrix build. This is going to be obviously no translation, no rotation, and a scale of 32. So we have 3 separate translations. It's 3 separate. I knew I was going to mess that up eventually. We have 3 separate transformations, and we, let's say, might want to combine these in different ways or combine them all together. So the way that you would combine 2 transformation matrices is actually not by like adding them together or anything like that. You actually want to multiply them together. And if you have any recollection of Algebra 2 in high school, the thought of multiplying matrices might have just sent you screaming from the room. But fortunately, we don't actually have to do any of the annoying work. GameMaker will do the actual matrix multiplication for us. We just have to tell it what to do. So it's not quite as simple as saying like transform translation multiplied by asterisk transform, like one of these other ones like transform rotation or anything like that. There is a function which is built into GameMaker called matrix multiply, which will do the work of multiplying matrices together for us. And you have to be a little bit careful about how you do this, because when you multiply matrices together, order does matter. So for example, if I were to say matrix multiply starting with transform scale and transform translation, we'll start with this, and we can save our, let's call it transform final equals that. Multiply these 2 matrices together and set that as our world matrix. This is going to give us something that's more or less like what we started with. So we have our treasure chest, which has been moved out some distance from the world origin like this. However, if we do this the opposite way around, and if I were to say matrix multiply transform translation followed by transform scale, this is going to give us something very different. And by something very different, I mean that the treasure chest disappeared. If you look closely at my screen, you might have actually seen it. It is off in this direction. And this is because matrix multiplication is what is known as non-commutative. So in like regular math, the kind of math that you're probably used to dealing with, if you have 2 numbers like 5 and 7, you get the same answer if you multiply 5 by 7 or 7 by 5. So that's the good old commutative property. But the same is not true for matrices. So if you do what I did before, if you matrix multiply transform scale and then transform translation, we are basically adding the second matrix into the first. So this is going to be a matrix which scales up our model. It basically multiplies the coordinate of every vertex by 32, and then on top of that, once we have all of our vertices scaled up, it's going to add the translation. So it's going to take the scaled up model and it's going to transform it. It's going to translate it rather 100 units off into in some direction, which just puts it slightly off center, like one of those big repeating squares on the floor, about that distance away. However, if we do the opposite, this is going to translate each of the vertices. We're going to like add 100 to the xy of every vertex, And then we're going to scale that up. We're going to multiply the position of every vertex by 32. And that now includes the translation. And the end result is that the model is going to like shoot all the way off into the distance. And this also applies to like rotation as well. So if I were to say, let's see. So how exactly do I want to show this off? So this is where the examples are going to start to get a little bit silly. So if we were to matrix multiply, and I'm going to say transform rotation and transform translation, and we can call this like var transform tr or something for translate rotate. So if you're thinking about the order of operations here, you might be able to guess what this does, and you might be able to guess how it goes wrong if you put them in the opposite order. Let me say our transformation final is going to be our scaled with our translation rotation multiplied into it. And this is going to give us, if I got everything the right way around, this is going to give us something that's basically what we had a little while ago when we were doing it all in one, building one matrix with the treasure chest like rotating about its own central axis. And that's usually what you want to happen. So again, if you think about like a 3D level editor with your rotation gizmos and whatnot, when you rotate an object, you want it to rotate about its own local axis. But if you're to flip these around, and if you were to put the translation first and the transform rotation second, this is going to translate the object, and then it's going to rotate it about like the axis, the central axis in world space, and that looks very silly, doesn't it? I'm not going to say you'll never want to do that, but most of the times you don't, and it is a good idea to mind your order of operations when you multiply matrices together. You will generally want to, let's say, start with your scale, add the rotation into the scale, or maybe I should say multiply the rotation into the scale, and then let's call that transform RS. And then you will take your combined scale and rotation matrix and then multiply that into your translation. You will generally want to, other way around, you will generally want to apply translation last. Let's see, that looks correct. It's generally not a huge deal if you get the scale and rotation one way around versus the other, as long as you have a uniform scale, like the same scale on all three axes. But if you do have a different scale and different axes, you can get weird shearing effects if you do your rotation before your scale. And you should pretty much always do your translation last if you don't want your scale and rotate to make weird things happen like we saw before. Let's see, so that's about it for transformations themselves. There's a few other details that I'd like to add that aren't super important, but you might want to know. One is that the rotation, translation, and scale are by far the most common 3D transformations that you might encode in a matrix like this. Others do exist. Very rarely you'll run into someone doing something funny with a shear matrix, which is another thing that you can do with a world matrix like this, but GameMaker doesn't have any built-in features for it. It's pretty rare that you actually want to use it. It is possible to do yourself by like constructing the matrix by hand instead of by using the matrix build function, but I don't consider it that important. I'm not going to get into it here. Another thing is that in currently future versions of GameMaker, and possibly by the time you're watching this video, the current version of GameMaker, matrix multiply will allow you to pass in a third argument, which is an empty matrix, basically, which you can populate with the results of the matrix multiplication, and you will see people yelling on the internet about how that's more efficient and how doing it like this is super expensive and super inefficient and whatever. They're not wrong for reasons which I will not be getting into here, but don't worry about that right now. Worry about learning the basics first before worrying about, like, you know, everything else. So I did promise some math, and because we are at the end of the video, I guess we'll do some math. So matrices, as you probably remember from school, are basically 2D arrays of numbers, and in GameMaker and also generally in computer graphics, you will be working with 4x4 matrices. Occasionally 2x2 or 3x3, pretty much never anything bigger than that. Anyway, if you have an array of 4x4 elements, the matrix might look something like this. It's not like vitally important to know how this works or anything, but once in a while it can be useful, and it is just an interesting fact besides. In a 4x4 matrix like this, you can encode pretty much any transformation you like.
Hey.
Can I, like... I have to say, I've never really messed around with layers in Windows 11 Paint, so I don't really know what I'm doing here. Do I not get any, like, fancy transparency controls? I wanted to, like, fade this out to, like, 25% or something like that. Whatever. Alright. Can't get too excited here. So, different parts of this matrix are going to encode different pieces of information. So, for example, the translation of a 4x4 matrix is going to be stored down here. In these elements, rotation and scale are going to be stored. Should I pick a different color? Rotation and scale are going to be stored up here. And there's all kinds of fun ways that you can mess with these 9 numbers specifically to create like scales and shears and rotations and all that. If you have an identity matrix, what exactly an identity matrix that represents like no translation, no rotation, and a uniform scale of 1 actually is basically a matrix that looks like this, with 1s on the diagonal going this way and 0s pretty much everywhere else. Which you might recognize as like 0 translation. And up here in the rotation scale part, this is such bad drawing. I feel like using MS Paint to draw stuff is like a YouTuber stereotype in the current day or something like that for some weird reason. But the only reason I'm doing this is because it's like 3 o'clock in the morning and I'm too lazy to go and like whip out a sheet of graph paper and film myself writing something down on my desk or something like that. Anyway, I'm not going to get too into how like each of these rows and columns and whatever works, but you can think of the upper 3x3 in a transformation matrix like this as like the local coordinate system of a rotated object. So you could take like each of these 3 columns, you could look at them as a vector in space, assuming these 3 vectors are at 90 degrees to each other, or orthogonal, as the math people like to say. That will give you like a local coordinate system, which will represent the rotation of an object. If all of these vectors have if all of these columns have a magnitude of 1, then it's going to be a uniform scale. If all 3 of these columns instead have like some larger magnitude, like 5 or something like that, then this will be then this matrix will also represent scale, so the object will be scaled up. And then, of course, down here at the bottom, we said that is the that is not what I meant to do. We said that this is the transformation, and that part is pretty straightforward. So if you have a transformation of like 15 and like, I don't know, 42 on the y-axis and like -3 on the z-axis or something like that, that would just be your transformation. This over here on the side, this is kind of like not used for anything. I don't know what kind of nonsense would happen if you mess with these values, but they're pretty much never used for anything in like everyday use. Anyway, the way that this all works is that if you took like 2 of these and if you like multiplied them together, you took the dot products of the rows and columns and added them together and whatnot. Yeah, I didn't pay attention in Algebra 2 either. I just let GameMaker do the matrix multiplication. Anyway, the result of doing all that would be that the output matrix has the combined transformations of rotation, scale, translation, and whatever else went into it. And from there, you say matrix set, matrix world, matrix whatever. The transformation information, this array of numbers, goes to the shader, and the shader then transforms the vertex positions and whatever else by your worldview and projection matrices. But that's a story for another day. Again, the internals of this isn't something you really have to know about, as long as you know what to do with it. But I did promise some math, so there's a high-level description of what exactly a matrix is and why we care about them so much. So I'm going to end this off here. If you want the code for this, look for the GitHub repository in the video description. It should be hopefully a little bit better than the last one. The last project of 5.5 years ago, whatever it was. My name is Michael. I like Wizards and Dragons and making games. I do like to post videos on weird stuff you can do in GameMaker, so if anything like this appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. You should all go check out Wizarducks and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff. Link to the Steam page can be found down below. I hope you all found that useful, and I will see you all later. Special thanks to Zenjamin, Squarecrow, Spy Die Games, Manta Ray, GameMaker, GameArt Indie, Edward Holt, DJ Gibbles, and Bokeh Dev for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.